So what we're going to do today is we've got, again, a few new things to kind of define as we're going through this stuff. We're looking at what are called biconditionals, biconditional statements, and some other definitions. What happened yesterday was that we were looking at kind of our logic ways of writing and talking about definitions, which nobody asked me a ton of questions. It doesn't seem like it was terrible. We had our conditional statement. Yeah, it was the if-then, but we called it P implies Q. The hypothesis and the conclusion. So the conditional was P implies Q. The next one was the converse. The converse was, oops, very good. And then we had inverse. I'm going to start using the symbol your new textbook does, the tilde. Not P implies not Q. Remember yesterday I showed you guys that one little upside down little 7 or an L or whatever. That's how I grew up learning it, but I'll use this one. Okay. But I always learned not as not P.
What?
Yeah, I learned that as not. But that's how I learned it. But yeah, we'll use tilde. It's fine. And then the last one was the contrapositive. Was not Q, was not P. And you probably noticed as you were talking about some of the definitions and you were writing those things out, that sometimes all of them were true, sometimes the first and the last were true, the two in the middle were false, sometimes the first and the last were false, the two in the middle were true. It always depended upon what you started with. And that kind of is the idea where this biconditional statement comes from. So we still use these guys, but we're going to use them in a little bit of a different sense. For example, first of all, before we get to be able to use all those, we have to talk about what are called conjectures. Conjectures is kind of like a hypothesis. It's just a different way. Instead of looking at a hypothesis within a statement, what you're doing is that you're making what's called an educated guess. All right. For example, if I look outside, knowing what the temperature how it felt this morning when I first came in, it was still a little foggy, and it was about 65 degrees. I could probably look out and say, when you're blowing the sun's out, I bet it's about 75 degrees out. You know, the idea of looking at a situation and taking an educated guess about stuff. In my honors class, past 3 days, we've been working on some pretty crazy linear programming word props. And as a teacher, you get these sense, you know how teachers can kind of sense where kids are at by humor questions being asked, and you get the idea of people like body language, like you see them kind of clicking along, they're doing the work. There's not a lot of craziness going on as far as I have no idea what I'm doing, and not everybody's raising their hand like that. It's more of I can take a sense of the feel of a room and see that I can continue on something. Yes, sir. I was close-ish. Thanks. But the idea here is you can take what's called an educated guess by looking at all the different surroundings, taking in the information within a certain area, and going with it. So that's what we call a conjecture. And like I said, conjectures are made on basic information. Okay. For example, if I'm looking at all you guys right now, I'd say about half you guys are bored out of your minds because the looks on your face are like this. That's all right. It's the idea that you can take a situation and come up with an idea of what's going on.
You guys do this all the time.
You do. It's how you read somebody. It's how you read body language. It's how you can interpret how somebody else might be feeling. Things like that. These are things that each person does, but you don't realize that there's an actual method that was really ingrained in your brain of something going on. So what you're doing is you're using what's called inductive reasoning to come up with an idea based upon situations to come to this conclusion, if that makes sense. So I'm looking outside, seeing that it's sunny, and I thought it was warmer out this morning, so I thought it had warmed up by now because the clouds are gone, the sun's come up, so I said it'd probably raise up about 10 degrees. My educated guess, air quotes, was that it got warmer out. Now, Mr. Quinn, he looked it up, and I was off by a few degrees. But it's still the idea that your guess, your ish, if you will, may not be perfect, but you're coming towards a conclusion of, all right, it's kind of in that idea. Okay? You're getting that, you feel the sense of it's getting there. All right. I'm looking, he's got a thing on his knee. So I'm making the assumption that something happened to his knee, maybe when he was playing football, he twisted it the wrong way, or he landed on it wrong, and something popped with it, he's holding it to keep a little pressure on it to help keep it straight, so it helps throw it out. It's those little things you see like that. Miss Thoreau's wearing heels. You know why she's wearing heels? Her daughter's getting married. So she wants to wear heels to practice walking around so she can dance around in the heels. All right. Yeah, that's she falls over. Joe, I need your knee brace. It would be great. All right. So come up with a conjecture. Come up with a conjecture of this situation. Don't write it down. Just read it. Just. This is a real sign. This was a real sign at a zoo that thought it was too funny. I had to take a picture of it. All right. Now, my family, my wife and I and our kids, we travel a lot during the summertime. We go camping. We go to all these different places pretty regularly. And this was a few summers ago. We went up. We were just outside of Door County. We were up by Lake Oshkosh, or is it Lake Oshkosh, Wisconsin? Yeah. So we're way up top there, outside of what's a little town called Neenah, Wisconsin. Neenah, Wisconsin is known for their steel foundries. If you look at manhole covers or water main covers or sewer grates on the roads, you'll see that most of them say made Neenah, Wisconsin. Yes, sir. Yeah. Oh, yeah. So outside of in Neenah, Wisconsin, they have this. It's actually on the Fox River, which is the Fox River you see out here towards Geneva and all that. It goes way up north. But Neenah, Wisconsin is a really cool little town, and they have this little zoo out in the middle of nowhere that had a whole bunch of animals that you were rarely surprised at. Like, they had a giraffe and a gorilla and a lion and all that. But this was one of the signs that were there. What's that? Oh yeah, they're all in one cage. No. So what happened here was, I thought it was just too funny because, all right, in my mind it's telling me that animals will get sick if they eat people. They would prefer not to eat people, but if you're there, so yeah. Dark.
So what did that imply? So that there's a guard dog who will kill you if you trespass. If you survive, dude, we're going to prosecute you.
It's those little things that it seems it's silly, but you get the idea of, all right, don't go in there. I don't want to make the zebra sick. Yes, sir.
I saw that sign once, and it said 24 hours of maintenance.
Speaking of which, there's a serial pooper in Colorado I saw in the news. So, we never get off task here. It's kind of a crappy story, but it's funny. All right. Anyway, sorry. Yes, okay. There's a story. There's a person who apparently is running. They do a lot of running, and sometimes they could find a facility, so they go next to somebody's house and they facilitate things. So there's a serial pooper. Speaking of, Alright, same idea happens when you can take crazy things and you can bring it back to geometry. For example, given points A, B, and C, if you know that AB is 10, BC is 8, AC is 5, what's some conjecture you can come up with? Hold on a second. Take a look at what you have. You have segment AB, segment BC, segment AC. Take a second and think about what conjecture you can come up with. You're right, they're not congruent because they're not equal value, not equal length. It's about that time of the year, isn't it? Now, what do you say, Josh? These segments. I think I know where you're going with that one, but you guys were saying that you're saying that the whole thing had to be 23. Is there any way that I can make these letters work where it would work out to be in one single segment?
It would be A, B, AC.
Who said that? It's a triangle.
It's a what?
It's a triangle. A, B, and C. The distance from A to B is 10. B to C is 8. A to C is 5.
What kind of triangle is it?
Scaling. All right. Now, the idea that it can't be one segment, what you guys were saying, they're not going to be collinear because if this is A, B is 10, B, C is 8, A to C would have to be 5. But if you do it that way, what would AC have to be? It would have to be 18. So that means this would be a false conjecture. I just disproved your conjecture. I used a counterexample via diagram. Does that make sense? All right. So that's the idea. You can use conjecture and stuff like that by given specific information. You're going to be able to draw diagrams, and those are also can be considered educated guesses. Not drawing a scale or anything like that, but that's just kind of what we're looking at. All right. Not terrible. Okay. And like we just said, sometimes conjectures can be false, and that's what we just did a second ago. You don't have to write all that out because their conjecture was that they were collinear. I disproved that by showing, and all you need is one thing to show that something is false, and then it becomes false. 10 and 8. And I can just say 10 plus 8 does not equal 5, and therefore I disprove your conjecture that they were all in the same line. Okay. That's what we're looking at. Pretty straightforward. Now, the next bit of this switches over to what are called biconditional statements. Biconditional statements are statements that are going to be true if you say them forwards and backwards. Okay. Biconditional statements are statements that are true forward and backward. No. Think of this in terms of P's and Q's. What's the initial way we go? Which is what in terms of P's and Q's? P implies Q, right? That means that is true, and then Q implies P is also true. So that's when you have a conditional. And then what was this one called? What's the second one called again? Converse.
Oh, so like if you're a pattern,
And then I see where you're going with that. If you're a batter, then you play baseball. But then if you play baseball, you're a batter. And I can negate that by saying in the American League, pitchers don't bat.
You go to college, you're in school.
So they can't.
What?
If you're in the NBL,
What's that?
baseball.
No. If you in the National League, pitchers hit, but in the American League, pitchers don't hit. That's what we call it. They have the designated hitter for the pitcher. I think they should get rid of that. They should have DH all the way around for the way that they have pitching nowadays. Yes, sir.
I remember one of the questions to the homework was if you play a sport with a bat, you're playing baseball.
Yeah.
That is actually fun.
You're right, because it's cricket, right? The cricket still they call it a bat, or they call it something else. Is it that? Yeah.
Softball.
Have you ever really watched? Any of you guys ever watched cricket?
I played.
It's weird. Cricket's really weird. They have this giant paddle, and they use a baseball, but the baseball itself is kind of like it's almost like it's a lot harder.
It's a tennis ball.
It's a little bit. It's about the size of the baseball, maybe just a little bit bigger, but it's more. It's heavier. And what they're doing is that there's a lot. You think there's a lot of standing around in baseball? They can't, and they have what they're doing is they're throwing it like 3 sticks. I think they're called wickets. I want to say. I don't quote me on this one. I tried watching. It was on TV once, and I tried watching. Like,
What is going on?
exactly.
It's like
What?
watching a TV show in the middle of what's going on.
Exactly. So the pitcher, I think they're called the bowler. The bowler is what we would call the pitcher, and they have the ball. And they take this running up to the spot, and they throw it at the guy who's batting. The bat is more like it's almost like a paddle, but it's not that wide. Yeah. And they try to hit out of there, but their fields are so much bigger. They're like playing like a soccer stadium type thing. Yeah, I don't understand it, but apparently it's extremely popular.
So I got one. If you play baseball,
What about Little League? All right, so let me show you an example of this. What we do here is, in 5 conditional statements, we use the term if and only if. What happens? Yeah, because it works going both directions. Now, instead of writing out the word if and only if, because it's so many words, we write it out as if. If and only if is IFF. Because you know us math people, we don't like to spell. Might as well abbreviate everything, right? Okay. What's that? Exactly. So let's see here. This didn't show up very well. A point is a midpoint if and only if it cuts a segment into very simple way of writing it. If you think about the definition of a midpoint, if you have a midpoint, then it cuts a segment into 2 congruent parts. If a segment has been cut into 2 congruent parts, then you have a midpoint. Abbreviations. A point is a midpoint if and only if it cuts a segment into 2 congruent parts. Shorthand. What's that? Well, I mean, you can write it out. It's just what I was trying to do was save a little bit of space. So, a point is a midpoint if and only if it cuts a segment into 2 congruent parts. And that, what I was doing there, a lot of times you'll see that I'm going to try and use like abbreviations because we know midpoint is MD. It's just cleaner, I think, sometimes to read it. All right. So that's what a biconditional statement means. It's true going both directions. If a segment has been cut into two congruent parts, then it has a midpoint. If you have a midpoint, then it cuts the segment into two parts. Okay. Not terrible? All right. Let me see. This is a generic statement. Two angles are complementary if the sum of their measures is 90. Let's write that as a conditional. Conditional statement means we're going to write it as if-then. So this is your generic statement. Two angles are complementary if the sums are 90. So how would you write that as an if-then? Yes, sir. Perfect. So what we write here is our conditional, our P implies Q, would be if two angles are complementary, then their sum equals 90. That's what that means. Yes, sir. Yeah. That's what that looks like in terms of what we call the conditional statement. Now, if I say that backwards, what do you get?
If the sum of two angles, if the sum of two angles are 90 degrees, then they're complementary.
Perfect. Both of you guys said the same thing. Okay. If you say that backwards, you say the converse of it, Q implies P.
Sum is 90,
If the sum of two angles is 90, then they are complementary. Is that true also? Yes. So what we can write it then is what we call a biconditional statement, because those both are true by putting the words if and only if in there. So the if version would be if two angles are complementary, if and only if their sum is 90. See how that works? Two angles are complementary if and only if their sum is 90. That's what it looks like in terms of starting with the conditional, P implies Q, your original if-then. Say it backwards, and then put it with an if and only if. It's not that bad, is it?
Yeah.
And quite honestly, most geometric definitions or geometry definitions are written as if and only ifs. Think about supplementary. Two angles are supplementary if and only if their sum is not 180. Excuse me. Two angles are a linear pair if and only if they share a common vertex and they create a line. Two angles are vertical if and only if their opposite rays create lines. So on and so on. Just about every definition that we've talked about, we can rewrite as an if and only if.